So a warm welcome to everybody to the semifinals. We'll just give it one more minute for the last people to join and then we'll get started. Hi everybody, a warm welcome and thank you for taking the time to join the semifinals of this year's Next Generation Water Action. Both to the participating students, the jury, the partners and the mentors who are joining us today through the virtual platform called AirMeet, and to those of you that might be joining the direct live stream on YouTube or the website. My name is Marie-Louise Polman Larsen. I'm a project manager here at DTU Skylab and for the Next Generation Water Action. I will be facilitating today's semifinals together with my colleague Levke Uben and with a fantastic team that is making everything run smooth today behind the screen. We are transmitting live today here from DTU Skylab, the hub for technology-based innovation and entrepreneurship located at the Technical University of Denmark. It's the fourth semi-final session we're doing today, and it's been fantastic so far to see the ideas presented by the students, but also hearing the reflections and the questions to the jury. So we're very much also looking forward to today's session. Together with strong partners, Next Generation Water Action has been able to invite and involve more than 100 students that since February has been working on 5 defined water challenges. The challenge that is defining the semifinals today has been together with the partnership between Ghana Water Company Limited and the largest provider of surveying and land management services, LE34. We're having 4 teams that are going to present their ideas and solutions today, as you can see here on the slide. And this is also showing the order of the pitching. So we'll start with the team from Denmark, then we'll have a team from Kenya, from India, as well as Ghana. So we are very much connecting across nationalities today on this virtual platform and super excited to get started. So the students have not only been working with their nationality and national perspective on the challenge that has been brought forward, but they also represent very different disciplines. So what you will see today is also a diverse palette on different types of solutions that are all trying to address the challenge that has been presented. So we hope that it's going to provide also a lot of inspiration and new perspectives for the people joining today. And following the pitches, there will be the opportunity for those of you that are joining on AirMeet to have more like an informal interaction with the student teams in the lounge that will happen after the stage show here. And for those of you that would be interested in being connected directly with one or several of the teams, on our website where we are directly live streaming the semifinals now, you would be able to offer acceleration time, which means providing a bit of time for providing sparring or mentorship to one or several of the teams here. So it's quite simple. There is a form. Feel free to share and propose yourself to one or several of the teams, and there will also be the link shared here on the stream for those of you joining AirMeet. But before we set the stage for the students, we also want to welcome our partners from LE34 and Ghana Water Company to set the stage before we get started. And of course, we will also challenge you to keep it fairly short, so we make sure that we finish upon time with the full semifinal. So First on the stage, I would like to welcome our representative from LE34, Rasmus Johansen, to take the stage and help me in welcoming the student teams. Rasmus, I hope you're with us.
I hope
with
so.
Sound. Yes, fantastic.
I don't know if my camera is working. I don't see myself, but...
No, we cannot see you yet. Try to activate it below in the panel, and sometimes it takes just a few seconds to appear.
Ah, there it is.
There you are.
Okay. So, in full glory and grey beard and grey hair. Yes, thank you very much. Yeah, thank you for letting me give you an introduction to LE34 and myself. My name, as you said, is Rasmus Lindne Johansen. I'm a chartered surveyor. I have been that for the past 20-some years. In my professional career, I have been working with mapping of on a country scale with autophotos and LiDAR production. I have, during 10 years, I've been doing 3D city model data production in projects in Europe, in Middle East, and in Asia. Lately, I've been a project manager on a nationwide panoramic street photo production and development of an online drone imagery inspection platform. So I've been doing fairly a bit of different work in my professional career. So at the present time, I'm involved in developing an Android app and an OS app called Smart Survey. And the object of this is actually to be able to acquire video data, process that into a point cloud. And it's especially directed towards utility excavations, where we, through this recording, can document, and after that we can also measure pipes after the dig has been covered up again. This result is then visualized in an online platform, which is called Point View, where we can store and share a large amount of data. So from my point, I'm very data driven, and that has been my topic for the past 20 odd years. So moving along, so why is this challenge important? And thinking about that, one of the things that come to mind is that water is one of the basic building blocks of life. So I think everything about water is important. And apart from that, I think it's also important for us to provide a meaningful stage that enables the students to perform the best they can and get deeply involved in their education and solutions to benefit all of us. So with that, I must say I'm very pleased to have seen the quality of the work that's been done by the 4 groups, the dedication that the teams have put into their videos and the blog posts is very good, astounding. So equally, I'm looking forward to the pitch and the following QA, and I wish the teams the best of luck and looking forward to all the presentations.
Thank you very much, Rasmus. And one of the things that we have also valued in exactly this semifinal and the definition of the challenge is that you are here bringing forward a potential partnership. So having a challenge that is targeting a geography and an area that is new for many of the teams, at least, it's been absolutely valuable that you have also brought forward the national partner to bring contextual insights, both related to, of course, some of the opportunities and the possibilities, but also making sure that the students have had access and insights into some of the challenges and some of the technicalities that might not be familiar with them, to also come up with solutions that is more prevalent to actually have a potential in the context where you are targeting the challenge. So what we're also very happy for today is, of course, you, Rasmus, to be part of this, but also to welcome your colleague or your partner, Maxwell Akroskusi, from Ghana Water Company Limited, that we also want to give a word to and have a few minutes to set the stage before we will set the floor for the students. So Maxwell, I hope you're with us.
I am with you, yes. Can you hear me?
That's great. Yes, we can hear you.
I cannot see myself. I don't know if you can see me.
We cannot see you right now. Try to activate the camera below, and sometimes it takes a few seconds to actually load it, but we hear you perfectly. Now I think you're muted, Maxwell. Yes, now you're there.
Is it working now?
Yes.
Okay. So I am Maxwell Akosa-Kosi, and I work with Ghana Water Company Limited. I have experience with GIS, data collection, basically in network management. I also have interest and have been doing what we call hydraulic network modeling for the past 12 years. I do design of water systems, and currently I am in charge of trying to make sure that we resolve the issues that have to do with non-revenue water. And like Rasmus said, he has a solution, and then I have a problem. Now, my problem is quite simple. It is that we are producing water in huge quantities, and we are losing quite significant amounts. Now, if you look at the challenges that we have with water supply on a global scale, then what that means is that we cannot afford to lose water that we have spent money to produce at the various treatment plants that we have all over the world, and particularly when we come to Ghana. So it means that it makes it very, very necessary that as a professional in the utility industry, in the water sector, we take steps towards making sure that we have reduced as much as possible how much water we are losing from whatever we are producing. In fact, if you come to Ghana, the situation is even worse in the sense that there are still a very huge number of people who go on about with their daily work without access to potable water, without adequate access, let me put it that way. So a lot of people do not have taps running in their homes. A lot of people have to walk distances to fetch water. And then on top of that, the little that we are producing, we are also losing quite a huge amount of it through leakages, through construction works, etc. So for me, when we came together for this collaboration, it was something that I found very interesting and something that I thought is going to help us. And having looked at the solutions that the various teams from Denmark, Kenya, India, and then Ghana have presented and shown in their blogs, I am quite impressed, and I believe that we need as a sector to be able to progress. I am particularly looking forward to us being able to move on beyond this point, beyond just demonstrating that there is some capacity for us to do more, and actually doing it and taking up the task of making sure that the vision, the solutions that these students are presenting today, will be able to put it to good use. So essentially, that is the little that I will say, and I want to wish all the teams the best in their presentations, and hope that the best team wins today. Thank you.
Thank you very much, Maxwell, for your introductory talk here together with Rasmus. It's great to have you on board. You can just mute yourself and stay up on the stage, because after introducing myself, I will straight jump over also to introducing the jury member, which of course you will also be part of. So my name is Levke. I have been the project coordinator, but also the Young Academics Track League, and therewith have been closely working together with most of the student teams during the last 3 months. And now, of course, I'm very excited to also hear the solutions that the team working on the LE34 and Ghana Water Company Challenge have brought forward. I will be facilitating the pitch session today, but of course we need a jury for the pitch session as well. So it's my pleasure to introduce the jury here today. Besides Maxwell and Rasmus, who we have already been introduced to and who have given here the first welcome talks as the challenge representatives, we further have from our very strong local partner who we have been developing also the partnership with Maxwell with, which is the Embassy of Denmark in Ghana. We have a representative here, Ole Pilgaard-Stutrup, who is a water specialist and counselor at the Embassy of Denmark in Ghana, and we're very happy to have you here on board as a judge today. Besides, also our initiative has been developed in very close partnership with IWA, so with the International Water Association, and particularly with the young water professional. So we were very lucky to have one young water professional from each of the participating countries on board, and one of them has been Jacob Emenke, who has not only been functioning as a young water professional mentor in our journey, but who's also an emerging water leader in the IWA committee. So welcome, Jacob. And then last but not least, we also have a representation of DTU Skylab here, our very own Linda Weiss, who I'm also very happy to welcome here. She has already been participating in the other semifinals, and it's really great to have you here join with your perspective, since Linda has been running the initiative the last 2 years. So it's exciting to see her questions now from the perspective as a judge. Great. I can see everyone is on board here from the jury, so that's great. A big welcome from all of us, and we're looking forward to the semi-final and the Q&A sessions. To get everyone on board before we get started, let me quickly guide you again through the pitch setup, so everyone knows what is going to happen. So all of the teams have been asked to prepare a 3-minute video pitch, which will be the main part of their pitches today. These videos will be shown here live. We will all watch them together. And while we do so, we get 2 representatives from the team on the stage. So once the video is over, those 2 representatives will be giving a 30 seconds live pitch, which will then be ended here, indicating with my bell that the time is over. And that leads me then over to the Q&A session. The way that we are facilitating the 4 minutes Q&A session with the jury will be that I would just kindly ask the jury member who has a question to unmute himself or herself, so I will be able to see that as an indication for a question. Great. Let's quickly just have a look at what are we actually evaluating today. So why are we having the semi-final? So the main aim will be to select 2 finalists from the 4 teams pitching today for our grand final, which is taking place next week on the 18th of May. At the finals, then, these 2 teams can compete for the final track award of the LE34 and Ghana Water Company Challenge, and also to compete to win some IWA World Water Congress tickets to travel here to Copenhagen and attend the Congress in 2022. Besides that, we also have 2 awards, which will be decided based on the scores of the semifinals, which is on the one hand side, the Best Pitch Award. So we're awarding the team with the highest score in the pitch criteria across all of the 21 teams with the Best Pitch Award. And secondly, we're also awarding here today, or looking and finding the team that will be winning the Acceleration Scholarship, which is a 1,000 euros Acceleration Award, which has been sponsored by LE34, which will go to the team that Rasmus and Maxwell will be selecting together. All of these awards will only be announced at the finals. So although we are having here quite some exciting scorings today, we have to wait until the finals to see what kind of results the jury has come up with. Perfect. I would say we get started. So I will give the stage in the next hour to our actual VIPs, which of course are the student teams, because the student teams have been working quite hard during the last 3 months, have been working on their solution and also on their pitches. And I hope that all of the students joining us here today are very much looking forward to their pitches, because it's of course not to be seen as an exam here, but we hope that you can also enjoy being on stage, which we are very curious to listen to your bold visions and ideas here, and you very much deserve spreading the word about your ideas. Great. Let's get started. The first team that we will be welcoming on the stage today is Team 1 from Denmark. And I will just put up the video, and then, as I said, while we're watching the video, we will get the student representatives on board.
Hello, we are Pipe Data. With the use of our mobile app, we reduce water scarcity in Africa. According to the United Nations, around 40% of the world's population doesn't have a reliable source of water. This is especially true in Africa, and Ghana's capital of Accra is no exception. Some sources say that around 50% of the citizens of Accra lack a reliable source of water, which is quite a lot. However, we have another problem. 49% of the water that gets sent through the network gets lost on the way and doesn't really reach its end consumer. How is this possible, you might ask? Well, non-revenue water has multiple causes, but one of them is bad water management. Construction workers in Accra often do a dig without knowing where the pipe is, and often it gets broken. This results in lost money, time, and resources for the construction companies and lost water for the Ghana Water Company. And you might think this is an isolated incident, but in fact it happens 500 times a month in the city of Ghana. And this is a huge loss for everyone, amounting in $1.7 million in 2020 in reparation costs, and of course a lot of other inconveniences for many people. But don't worry, we're here to save the day. Our solution is quite simple. Make the visualization as easy as possible through the use of a mobile app. So let's see how our app looks. Here it is. We have taken Ghana Water Company's geodata and mapped an entire neighborhood of Accra. This enables construction workers to know the precise location of underground pipes. Easy to access. The app already has an augmented reality mode where you can see the pipes directly on the street through the camera in front of your eyes. It doesn't get any easier than this. And you might ask, okay, but who benefits from this? First off, the construction companies will benefit, who will avoid the large reparation costs and the lost time associated with them. Secondly, the Ghana Water Company will lose less water and have a much more service. Last but not least, the citizens of Accra will be spared a lot of inconveniences like water shortages and small floods. We believe we can create a win-win-win situation with our prototype. Talking about the business model, our clients are the construction companies, and with a monthly subscription, they can save money on their side and make a difference in fighting climate change. The Ghana Water Company is our strategic partner. They provide us the geodata, and in return, we reduce non-revenue water. The initial implementation plan of the product will take about a year. Initially, we'll make a proof of concept in Denmark. Afterwards, we will do a pilot project in Accra. In the meantime, we'll get in contact with the United Nations and the World Bank for financing and exposure. A full launch in Accra is step 3. We aim to have all the big local construction companies on board. Since the project is scalable by its very nature, we aim to expand to other big cities in Africa as well at the end of stage 3. Again, our vision is clear: avoid wasting water, and thank you.
Well, I think that was a great first pitch video that we were allowed to see here today. So congratulations to the team, which of course has not only consisted of Ralitza and Marius, who are here joining us on the stage today, but also of Anna, Dusan, Mohammed, and Dennis. So congratulations for a very nice pitch video. It's great to have you here. As you know, you will have now 30 seconds to add a live pitch to it. I will be taking the time right now, and the stage.
Hey, I'm Marius, and I hope you liked our presentation video. I wanted to add the fact that in order to make our prototype work properly, we found out we need some additional pieces of hardware, which will be procured with the help of your 1,000 euro grant if we get that. This is because the GPS coordinates need some kind of special antenna in order to work properly. And I hope with that we'll be able to create a prototype and then launch the pilot project in Accra and then get feedback from the people in the field. Yeah, I think that's it.
Perfect timing, Marius. Thank you so much for adding the 30 seconds live pitch here. And now I'm very excited to see and hear the questions of our jury members. As I said, you are very welcome to just unmute, and then I will give the word. And I can see that Ola has already been unmuted. So Ola, you're very welcome to give a comment or a question here to the team and kick off the Q&A session. We can see that you are unmuted, Ola, but unfortunately we're not able to hear your sound.
Okay. All right, that's better. Thank you very much for this very clear and convincing video demonstrating what are the benefits of that tool, a strong tool you developed. Sitting here in Accra, for me, I can really see how that could work out in the streets and provide a huge benefit for all the stakeholders involved in this kind of activities. So congratulations for that. And I like the way you the sky is the limit for you, I can see. So how you foresee the development of your product, the commercial side of it, and the benefits for all stakeholders around it. So really nice work, I think. Congratulations.
Thank you. Thank you.
Thank you very much for your warm comment here, Ole. Great. Let's see. Does any of the other jury members here would like to pitch in with a question? I can see Jacob unmuted, and you're welcome to ask a question to the team.
Yeah, thank you. I like how you define the problem, and they're so well explained. My question is, do you have a fair idea how much this solution will cost?
We believe that in around a year of development, we'll be able to take it to market. So that would be maybe 2 developers' salaries for a year. And it depends where you have your developers, but if you have them in Denmark, then back of the paper calculation, maybe upwards of, I don't know, 500,000 crowns. But yeah.
Thank you for giving us some insights here in your calculation and the thoughts that you're putting into this. And then I can see that Rasmus has a follow-up question, and you're very welcome to pose it.
Thank you very much. I've been following your team quite closely, so I'm still amazed about the progress you've made. I would like to ask you the question here, because it is a new tech, but old tech might also give the information. So how does your app provide more information than an old-fashioned printout map?
Yeah, so it's like, why is it better than just printing out a map? Well, first of all, we think it's about this thing of accessibility. If you want to get a map, you need to sort of go through a process of acquiring it. You need to go physically and get it. But through an app, all these things could be sped up a lot more. So the whole process of application for a specific region to map and to give that application could be made much faster through the use of new tech. Also, being interactive, that can make it sort of easier, and having this AR thing might help with people that don't know how to look at maps, and they don't really need to know. They just need to know that right in front of them there's a pipe and they should not hit it. So in a way, we're trying to make it easier to use for people who have no experience whatsoever in looking at maps.
Yes, and we also heard of people having to use 60 different PDFs or other maps on their phone. So by using this type of application, it will be easier to know where they are in the space and see the mappings around them, instead of going through a lot of different papers and trying to find.
Perfect. I would say, Ralitza and Marius, thank you so much for joining us here on the stage, representing your team today at the semifinal. You have done a great job, and I hope you will stay on the call to listen to the other pitches. Great having you.
Thank you.
Great. I think that was a great start here for the session. And now I'm very excited to introduce the second team, which has been Team Kenya. So the next video or pitch video that you will be seeing has been developed by Miriam, Nancy, John, Walter, Daniel, and Rosemary. And I will put it up, and then we will make sure to get the according student representatives on the stage as well.
As a result of increase in construction activity, Ghana has experienced total losses because developers are not able to identify the location of water distribution networks. This has led to pipe damages and consequently water losses. It is therefore important to map out and classify these pipe networks.
Our solution focused on development of an Android application. The application will be showing the location of pipes by, first, showing the pipes in the vicinity of an upholder, and second, showing the distances between these pipes at the upholder's location. The data to develop the app was obtained from Dedan Kimathi University of Technology. This is due to the need to test the app and also due to time limits. A Garmin GPS was used to obtain the coordinates of imaginary pipes, which were used to develop the app.
This is a mobile application that is based on the information that is on Google Earth. So the interface of the application is based, or is such that when you open the application, it will know your exact location and it will show you the locations of the pipe. And it will also show you the distance to each pipe from where you are, and it will calculate the shortest distance to the nearest pipe.
Our supervisors have good experience in water engineering and mechanical engineering, and also in diverse fields as problem solvers, as we have civil engineers and software developers. If we win this award, to be able to make this application a reality, and hence can be used in Ghana and in any other country that is facing the same problem of water losses, as a result of not knowing where the pipes are located.
Thank you very much to Team Kenya here. A very great video as well, and I very much enjoyed that you also included the call to action in the end. So great, congratulations for your video. I can see they are not on the stage yet, however we are trying to get them on. We are already in contact with them, trying to make them join us here on the stage. As long as we're waiting for that, maybe one of the judges just has a comment on the video and that we could listen to. And Miriam is there, great. Can you hear us well, Miriam?
Yes, I can hear you.
Perfect, I'm glad to hear. Well, then let's pivot the plan. Let's give you, of course, first, together with John, your 30 seconds of adding a live pitch. I will start the timer and the stage is... You're welcome to give your live pitch in case you're ready for it. Just let me know and then you can start. Okay, I can see lost connection here. John, are you still with us here?
Can you hear me?
We can hear you again, Miriam.
Okay.
Are you ready to give us your live pitch?
Ensures... Yes, I'm ready. Okay, so our Android application ensures that both the semi-skilled, the unskilled, and anyone else who wants to know the location of the pipes can be able to do it through their phone. So once you get and you open your phone, the app can be able to show you all the pipes that are located near your vicinity. Hence, it ensures that if you are doing any construction activity near that area, you know the exact point of the location of that pipe.
Perfect. Great timing. Thank you, Miriam, and good to see that your connection is running up smoothly. Great to have you on the stage. Then let's see if one of the judges would like to go first ahead with a question here. Then please feel to unmute and I will see who that will be. Linda, you're very welcome to ask your question to the team, to John and...
Yeah, first of all, thank you, John and Miriam, and the rest of the team for your great video presentation, and also now the pitch, and fantastic to see that you had the possibility to do some field work. What I'm now interested and curious to learn, if you already had the possibility to get some user feedback and what their feedback has been, if you had the possibility to do so.
Pardon, a question again?
Sure, I'm curious to learn if you had the possibility to reach out and test your solution among some users, and if you have already had some feedback from them on your application.
We haven't yet had a chance to be able to test it in the field, but after we designed the the prototype, we went where we took the coordinates and we checked whether it is working. It is showing us the location of the pipes. That's what we have been able to do so far. But we are hoping in the next few weeks be able to take it to the users and test it.
Perfect. Thank you for giving us insights in your process here, Miriam. Great to hear that you're planning on integrating users. We also got Nancy here on the stage, who's also part of the team. Great. The next question, let's see, any of the jury members, please feel free to indicate by unmuting yourself for the next question or comment for the team. Rasmus, you're welcome to go ahead.
Okay, thank you very much. I'm also very pleased to see the result of your video and your blogspot. I would like to ask the team if you have any knowledge of existing apps that can show GIS data and display pipelines already.
All three of you are still muted, so the one team member who would like to take the question, or of course you're also welcome to complement each other here on the stage, are welcome to just unmute and give some insights for Rasmus. Are you still with us with sound, Miriam, John, and Nancy? Can any of you give me a quick sign that you're still on the call here? I can see the Wi-Fi lowering of Miriam. Okay, in case you're experiencing network issues, I can see Nancy. Great. Hi, Nancy.
Hi. So in our research, we identified some GIS software. Then we also worked with like ArcGIS and MarketGIS, which is used to survey when surveying experiences and once in a while. But in this specific case, it doesn't use. It isn't used to identify pipelines. That is why we're creating our own app, because it wasn't relevant in this specific case.
Also, our application has the capacity of allowing for feature changes in that we can modify it with the time very easily, meaning a change which can occur today can be modified today, and then the next day it is reflecting the app. So it will be somehow efficient than the.
Great. Thank you for adding your inputs here, which very well complemented. The time is almost over for the Q&A session. I would say thank you to the team. Great having you on stage. Super cool that it still worked with your Wi-Fi. And of course, we highly appreciate your efforts here to be joining us on this call. So thanks a lot. Then it's me leading over now to the third pitch of the day, which has been composed by our team, one from India, which consists of Rudri, Kaivan, and Vatsal. So while I'm putting up the video, we hope that we have representatives here on the call as well, and then again getting them on the stage.
Water, water everywhere, still not a drop to be found. About 1.8 billion people globally will face very high water stress by 2025. At least 2 billion people use drinking water source contaminated with feces, which is very unfortunate because on the other hand, 38 billion liters of sewage water is wasted every day in India due to sky-high maintenance and manufacturing cost of sewage treatment plants. Another persistent problem is leakage in sewage pipelines, which causes sewer gas odors, decreased draining capacity of toilet flush, crack in the foundation, damp and mold spores. So what do we plan to do about it? Sixi uses IoT to make water smartly come back to our houses. We have developed a solution not only to detect the leakages in the sewage pipelines, but also to optimize the sewage treatment so that you can easily and happily decrease 70% of your wastewater. 6C Smart membrane bioreactor technology reduces maintenance costs by 60%. Not only that, it saves up to 60% in aeration costs and gives the least carbon footprint. We plan on applying machine learning and reinforcement learning on the database to know the pattern of usage and provide data to the government. It's saving someone's life with your money. You want to make it larger on your pocket too. We present the concept of STP on lease. We will install an STP for your building and will charge less than 7 paise per liter.
When the submersible pump is turned on from the website, dirty water from collection tank enters the first tank, which is denitrification tank. The denitrification tank is an anoxic tank in which nitrogen dioxide is converted into dinitrogen by Anammox bacteria and released in the air. When the anoxic tank is full, water enters from anoxic tank to aerobic tank through overflow. The recirculation pump is a centrifugal pump which is used to pull water from the second tank into the first tank. The membrane bioreactor module, which is an ultrafiltration module, is placed in the second tank, which pulls water into the membrane through by suction pump. Vega AS1061 microprocessor is used to control all the pumps used in the unit as well as the blower. The blower pipe is placed in the second tank, which is aerobic tank, to enable dissolving of oxygen into the water as a food to the aerobic bacteria. This is pH regulation program centered at 7 pH. We use Vega AS1061 to turn on the relays for acid dosing pump whenever the pH of input water is basic. Chlorine dosing pump will be added to the last tank and thus the purified water can be obtained. In the MVP we are using acrylic tanks, but for the prototyping of pilot plant, we'll have to use MS-FRP tanks, add a rotary mechanical screening for screening of solid waste, and an MBR module in the last MBR tank. The ammonium ion sensor as well as the dissolved oxygen meter will be mounted in the aerobic tank. When the ammonium level of the water increases, dissolved oxygen level must be increased by increasing the blower speed. When biological oxygen demand of the water increases, recirculation should be increased and thereby drain is decreased. This control loop mechanism will decrease the dissolved oxygen requirement and thereby decrease the power consumption and operational cost. Hall effect water flow sensors are embedded in source node as well as tail node. The change in differential flow between source node and tail node would be able to detect the leakage automatically. By performing machine learning on the sensor data, we will optimize the parameters of STP in order to obtain best feed water quality with minimum power requirement.
And now I'm unmuted. Perfect. I was just saying congratulations to the team as well here, and I can see some virtual applause flying in here, and also from my side, congratulations on ending up with a very great video, Rudri and team. I can see Rudri has joined here on the stage. Great to have you here. I can hear you audible. So the stage is yours.
Another one of my team members, Vatsal Safa, is also in the attendees list. Can you please add him?
So we're missing Kayvan in here on the stage.
Yes, ma'am, I'm here.
Perfect. I think you're there.
Yes, ma'am, I'm with Rudri.
Ah, great. Now I got it. Perfect. Good to have you both joining from one device.
Yes.
Then I would say we have 30 seconds here for your team, and the stage is yours.
Yeah, good evening. This is Rudri Pandya from 6C Resources. This is the first time that we are trying to implement machine learning algorithms in order to optimize the sewage treatment plant. In addition to this optimization of sewage treatment, as well as connecting it with the IoT, we also come up with a solution to find the leakages in all the sewer network and sewage pipelines. How we are going to do that is, first of all, we'll detect a leakage between the pipeline network by using water flow sensors, which are Hall effect water flow sensors. And then we will pass a robotic mechanism into the particular pipe which we have found out that there is a leakage in that particular pipeline. We'll pass the robot through that pipeline and find out exactly the point of leakage. Thank you so much.
Thank you, Rudri, and Karen here for being on the stage and for your pitch. And I'm very excited to see what kind of questions the jury members will have for your team. Maxwell, I can see you're unmuted. You're welcome to go first.
Okay, thank you, Rodri, and your teammates. Congratulations for your pitch. I wanted to know if, from what you are saying, you require a physical sensor. Did you research into that? Into what exactly the sensor you require to do this, to activate the AI you speak about?
I think we would need to, I can see Rudri is still muted, but at least at your network issues or the connection was a little bit hard. Could you repeat your question, Maxwell?
Okay, so what I'm asking is that what kind of sensor are you looking to install to activate the AI?
Okay, there are two types of, the first is Hall effect water flow sensor, which is connected to which has output in milliamperes. That will be connected to our microcontroller, that is a Vega AS1061. And that will be connected directly from ESP8266 device to internet. If I get the question correctly, the type of sensors that we're going to use is asked.
Perfect. Seems to be clarified the questions. Thank you, Rudri. And let's see if we have a second question here from the judges. I can see Linda unmuting, and Linda, you're welcome to pose a question to the.
Yes, and first of all, I also wanted to highlight when I first started the video, I was like, okay, that sounds very unfamiliar, and it's great that you actually updated it to make it a little bit more clear what your problem is and then how the solution is tapping into this problem. So fantastic to see that. And also great to see a prototype actually already in place. What I'm curious, like, now, moving forward, have you identified any collaboration partners that you would need to reach out to, or you would get in contact in order to, bring your solution forward?
Yes, we did this. We started this work 2 months before. So we reached out to all the industries. According to that, we've received 2 main orders. And 2 main orders and 2 main collaborations. First is with High Tech Water Solutions Private Limited, which has sponsored our project and has facilitated installment of the project into their site. And the second one is there's an NGO in which there's a no profit, no loss basis contract. So these are 2 collaborations. And further on, I wish and hope to collaborate with more partners, with Niti Aayog also.
Great. Thank you for giving us also some insights here in your previous journey, already having worked on some parts of the solution. Great to hear.
Thank you.
We do have time for one last question, so let's see if there is a judge. Rasmus, unmuting here, and you're welcome to pose the last question to our team from India.
Thank you very much. I think it's an impressive setup that you've developed. My question is that in your roadmap, you list 20 clients and then 50 clients and so on. Do you see already a demand for a setup like this? And do you see the possibility of raising money, equipment, organization, and so on, so fast as you indicate in your roadmap?
Okay. To answer the first question, the demand for STP is going to be increased, and particularly for MBR system, which we are working on, because of the current allocation of sanitization, sewage treatment in the budget of Indian government. Secondly, in all the other places also, as we can see, the freshwater resources are decreasing. So there's a need of smart sewage treatment system. Whether it be me or some other startup, we have to develop a smart sewage water management system. Second question, to answer your second question, we have been into this challenge from Indian government, Swadeshi Microprocessor Challenge. So we were the semi-finalists of that project, and henceforth we were able to gauge the money for product prototype of this project. So this is amalgamation of two, and the money that that was sponsored through that, we have used it to prototype this project.
Great, a perfect statement to end the Q&A session here with Rudri and Kevin. So thank you so much for joining. And I think it's more than valuable also to emphasize, of course, the situation that the Indian team have been going through during the last months with the health crisis in India. So thank you so much, and we're very admiring you for still delivering a great pitch video, revising it and being here live on stage. So all our thoughts are also with you in India, and thank you for joining us here on our stage today.
Thank you.
Great. That leads me over already to our last team here up in the row, which is our team from Ghana. And the team from Ghana consists of Francis, Edwina, and Peter. And again, I will be showing the video, which I hope you will be enjoying. And while we're doing that, we get the team on the stage.
Clean water flow through our homes, through pipelines connected from clean water sources. The result of the 2000 population and housing census of Ghana indicates that about 40% of the households in the country have access to pipe-borne water. 1/3 of the households obtain their drinking water from wells and boreholes, while 25% of the remaining household depend on natural sources such as springs, rainwater, rivers, streams, and lakes. In Ghana, most rural households do not have access to pipe-borne water. Because of this, they depend on natural sources of water, which are sometimes contaminated. The effect of water from unprotected water sources on health is much more acute among rural residents in Ghana. There are so many diseases caused by drinking contaminated water, such as cholera, dysentery, bilharzia, trachoma, and many others. In Ghana, real water losses and scarcity is a major problem that has been affecting the Ghanaian society. Real water losses are caused due to leakages either on the main service lines or during water storage. Water is lost through broken PVC pipes, which are often buried in the ground. Due to our third-class road systems, most buried pipelines are exposed to the surface due to movement of vehicles and actions of rain and soil erosion. These exposed pipelines on the surface are mostly faced by unfavorable conditions, therefore causing the pipelines to break or leak, which eventually leads to water shortage and loss of water. In order to reduce water loss and scarcity, according to the International Water Association, real water loss can completely be eliminated. According to the Ghana Water Company, most pipelines must be installed 2 meters below ground level in order to prevent bursts and leakages. Due to our third-class road systems, most pipelines are exposed to the surface due to soil erosion and constant movement of vehicles, therefore causing pipelines to break and leak out water. In order to eradicate water losses, a flexible pipe would be created. This flexible pipe would be resistant to loads of vehicles, the earth, and other external forces. Because of its flexible nature, the pipe will adapt to various environmental conditions. This is achieved by adding plasticizers, which are chemical additives added to polymer during polymer processing to increase workability, flexibility, and processing abilities of polymetric materials. A DMA leak monitoring can be done by installing meters at strategic points throughout the distribution networks, with each meter measuring the flow into a specific zone which has a well-defined and permanent boundary. A DMA meter will detect leakages and break occurrences within these pipe zones, which can be tended to and repaired to avoid water losses.
Thank you very much for Team Ghana here for pitching their solution here on our stage in their virtual video pitch today as the last team on our stage. And it's great. I can see both two representatives here, Peter and Edwina, have joined the stage. Can you quickly give me a heads up whether your audio is functioning? Hi, Peter. Can you test the sound?
Hello, can you hear me?
Perfectly. Great. I will be timing your 30 seconds and the stage is yours.
Okay, so mostly in Ghana, we lose water through our broken pipelines, and then most of our water bodies are contaminated. And we mostly face water issues on the local level. So we are planning to modify our pipelines to be flexible so that it can resist unfavorable conditions that we are facing in Ghana.
Great. Thank you for your live pitch as an addition here to your video. Good to see you both. And yes, let's see what the judges, what kind of questions the judges have prepared for you. Does any of the judges feel like going first here with a question for the team? Maxwell, you're very welcome to go with a question.
Yes, hello. Congratulations, guys, for your pitch. I'm particularly interested in the material that you said would be expensive.
Unfortunately, we're having sound issues to understand you well, Maxwell. Maybe it would be a solution to have Linda here first asking a question, and then maybe you could put your question in the chat. So on the right side panel here, you can see a chat function where you're very welcome to put in your question. And let's take Linda's question first, and then afterwards revisit your question in the chat.
Yeah, super. Thank you. And also thank you to Peter and Edwina for the great pitch video and your solution. I was just curious if you have assessed the business case to it and maybe put a cost structure to your solution. And maybe you can elaborate a little bit on that if you.
Please, can you come again with your question? We're facing audio issues.
Of course, sure. If you want to, I can also put it in the chat instead. But I was curious to understand if you have made a business case and kind of explored the business scenario to your solution, and maybe you can elaborate a little bit on this and also the cost part of your solution.
Okay, thank you very much. Yes, clear. Thank you very much, Linda, for your question. So I'll come to our normal homes. We use the PVC pipes. That PVC pipes themselves are less expensive. And then the PVC pipe, because they are mostly exposed to the surface, according to the Ghana Water Company Limited, they are supposed to install PVC pipes 2 meters below ground level. And then when you come to our local level, they normally don't follow those rules and regulations. So you normally leave those pipelines are normally exposed to the surface, and
they face unfavorable conditions causing them to break and leak out water. So the normal PVC pipes themselves are less expensive, and then we adding materials to the PVC pipes to make them flexible and also to make it resistant to these unfavorable conditions. We checking the market evaluation, we realized that we want to do something that is cost that is affordable and also something that is eco-friendly, so that the local community and everybody can afford it. So on the market, on the market it's less costly. Let me put it.
Great. Thank you very much for your elaborate answer, Peter. Let's see if another judge has a question for your team here. I could see in the chat that Maxwell was having the same question as Linda, so that's great. Our judges complimenting each other here with the questions. Ola, you're welcome to post the next question.
Yeah, thank you. Thank you, Peter and Edwina. Just a question. You mentioned the DMAs and you monitor the flow in and out. What systems and what equipment will you use for that? The small boxes indicated in the video.
Okay, thank you for your question. With the DMA meter, it is a meter that measures the flow of current through the pipelines. And then these DMA meters are going to be installed at various sections of the pipelines. So imagine there is a leakage somewhere. The current that is flowing through those DMA meters, the meter is going to signal. The meter is going to give us a signal that will tell us that the amount of current passing through this meter is low. So we should check whether there is a leakage or something there is a leakage or something in this particular pipe. So the DMA meter deals with pressure. That is the amount of water passing through a specific pipeline. So sensors that they use are pressure sensors. So it's going to use pressure sensors to detect the flow rate of water.
Great. Thank you.
Perfect. Thank you so much for the team from Ghana. I think it was a great closing statement here, not only for your own pitch session, but then, of course, also for the overall pitch session of the semi-final. So a virtual applause here for Peter and Edwina. Thank you so much for joining us on the stage. It was great having you and listening to your rather bold idea, but really, really great. Well, yeah, I'm excited about all the ideas that have been presented here today. And of course, what remains from my side is mostly to thank all the students for their hard work that they have been putting into developing the ideas, but then, of course, into developing the pitches. And I think it's great to see that not only in one country a solution is needed, but that there are across global collaborations and countries very similar solutions and strong partnerships needed. So great to be seeing that here. Yes, thank you so much to all of our judges for joining us here today. It was great having you. It was a pleasure to have you on board. And also thank you so much for your prior engagement of reading the blog post and also watching the pitch video. We hope you enjoyed the experience here. And we're excited to listen to the announcement at the finals of what came out of your scoring. Great. Before I hand over the word to Marie to close the session in the end, I would like to invite Rasmus on the stage again to be reflecting upon the session and maybe also just giving some closing words here to the teams of the collaboration that Rasmus and Maxwell were having. So the stage is yours.
Thank you very much. You can hear me and see me? I think yes. All right. So now we've seen 4 very good presentations and performances here today. You've given both me and I think all the others a good experience. The initial problem which was set out in the challenge has been adapted in 4 different ways, and you have applied your own solutions to the problems, and you've worked on many different solutions. So from very practical solutions to more theoretical ideas, but all with a business mindset and a convincing pitch, I believe. So apart from the obvious fact of producing a result and entering into a competition and winning it, the main benefit of this is knowledge and the experience that you take away from this challenge. I bet that each one of you is more experienced than you were 4 months ago, and each one of you is a step closer to the professional life. And thereby you are also one step closer to changing the world. one small step at a time, but every little step is an important step, and together with big leaps, in combination, it all moves us forward, and that's important. So from my side, I think continue putting one foot in front of the other, meet the responsibilities of education to be better than before, apply your knowledge to change the world. So from that, I hope that you all had a great challenge and that you will leave this one both wiser and happier in the future. That's my closing argument or closing statement here.
Thank you very much, Rasmus. And as you're saying, I mean, it's not about closing and wrapping up, but it's encouraging the next steps and how they can also drive this through the knowledge and the network and the ideas that they have been given here. We will also love to give the floor to Maxwell just to have a few closing remarks before I will end the session now. So, Maxwell, the stage is yours.
Thank you. I think what Maxwell said, it is very difficult for me to say, but what I would say is that these are really very innovative and important solutions that we've been able to come up with within a very short time. And I believe that the students going through some ourselves who have been our professionals are facing in the real world. And so, like Rasmus said, let it not end here. Let this just be the beginning point for you to do greater and better things to help the society that you find yourself. I particularly am very interested in moving some of these solutions, particularly the winner, to the next stage where we can collaborate more as the objective of this challenge is to collaborate on a global scale so that we can take this forward and see what we can get out of it. All the best.
Fantastic. Thank you very much, Maxwell. I think that was super encouraging words to all the student teams here, that I know a lot of them are quite eager to see how this can also pave the way for this solution to have a further impact, but also the learning that will bring along the way. So thank you very much, Maxwell. I will be closing the session now. First of all, I want to echo what Levke was mentioning before, which is to thank all the student teams, but also the mentors and the partners along the way. We're in a situation globally right now that makes it difficult for us to connect physically, and even more so be able to do field studies, work in teams across borders, but also even at the same university having the struggles of not being able to do that together. So I want to thank all of you for taking part also until the semifinals here. I think it's been fantastic also to see how you have used the platform of communicating your solutions through videos. I know that you have inspired each other as well, and seeing how that can be an opportunity to communicate new innovative solutions also going forward. As also mentioned, we will host the finals on Tuesday. You are all very much invited, and we're going to announce the 2 finalists that's going to pitch live during the finals, but we will also close the finals by actually announcing some of the awards that you are already now competing for. We are doing a open public live stream of the finals, so you are very much encouraged to spread the word and invite colleagues and relatives and partners to listen in and join through the website. We will also very much like that you encourage people that could be interested in providing acceleration time to look at that opportunity as well on the website. Then as a final remark, so those of you that are joining directly here from AirMeet, when we are closing the stage session now, you will go directly into the lounge again, and you will have approximately 20 minutes where you can have an informal follow-up conversation, digest some of the inputs that you had here, but also have the opportunity to maybe clarify a few additional questions and just be able to connect with us facilitating the session now. So on behalf of DTU Skylab, I want to thank all of you for contributing to the semifinals. It's been absolutely amazing to have all of you live virtually here, and looking forward to see you at the finals Tuesday next week, the May 18th. Thank you to all of you, and have a